Alright, so in this video I'm going to show you how de Broglie predicted that electrons must also have a dual wave property, like photons, like light. So based on Einstein's special relativity, right, special relativity, energy of a particle is defined as E squared is equal to m naught squared c squared plus p squared times c squared. Now this is essentially the this I'm just gonna write this as e naught squared. Now this is essentially the energy of a particle traveling at a speed close to the speed of light, right? So now for a photon, it's pretty damn clear. So you can rewrite this as E squared is equal to m naught squared times c squared plus p squared times c squared, right? And essentially for a photon, we don't have a rest mass, right? So m naught is equal to 0, and therefore E squared is equal to p squared times c squared, or E is equal to p times c for a photon. Now, we also know that E is equal to h times F from the photoelectric effect. So if we put these equal to each other, so HF times PC, and we know that F is equal to C over lambda. Am I going correctly with this? Yeah, I believe I am. So H is equal to H times C over lambda is equal to PC, and the C's cancel out. Essentially, we're left with lambda is equal to H over P. And so this is the wavelength for a photon. For a photon. And now de Broglie hypothesized that electrons and other particles like protons and basically particles that we expect that are particles, but in reality they also have a wave-like behavior like light and photons. And so by doing an experiment, they discovered that indeed electrons have a wave-like have a dual wave property, and so its wavelength is also equal to h over p. But since electrons have a mass, so we can write their momentum as mv. And this proves that electrons have a wave-like property, and this shows the symmetry in nature. And that's it.